Which of the following techniques are commonly used for feature scaling in machine learning? A. Standardization. B. Normalization. C. Min-max scaling. D. All of the above. True. Standardization. Z-score normalization is a common technique used for feature scaling. It transforms data to have a mean of 0 and a standard deviation of 1. This helps in bringing features to a similar scale, which is often beneficial for machine learning algorithms. True. Normalization. Min-max scaling is another widely used technique for feature scaling. It scales features to a range between 0 and 1. It's useful when features have vastly different ranges and you want to bring them to a common scale. True. Min-max scaling is a feature scaling technique that scales features to a specific range, often between 0 and 1. It's particularly useful when features have vastly different ranges and you want to bring them to a common scale. True. All the options standardization, normalization, and min-max scaling are commonly used techniques for feature scaling in machine learning. They are effective in addressing issues arising from different scales of features, which can impact the performance of many algorithms. D. All of the above. Feature scaling. Feature scaling is a pre-processing technique used to transform features to a common scale. This is important in machine learning because many algorithms perform better when features are on a similar scale. This helps to prevent features with larger ranges from dominating others and can lead to faster training times and improved model performance. Standardization. Standardization, also known as z-score normalization, transforms data to have a mean of 0 and a standard deviation of 1. This is done by subtracting the mean from each data point and then dividing by the standard deviation. Standardization is often preferred when the data distribution is assumed to be normal or nearly normal. Example: imagine you have data on the heights of people in two different cities. One city has an average height of 510 with a standard deviation of 2, while the other has an average height of 56 with a standard deviation of 1. After standardization, both datasets would have a mean of 0 and a standard deviation of 1, allowing for fairer comparisons between the heights in the two cities. Normalization. Normalization, also known as min-max scaling, scales features to a range between 0 and 1. This is achieved by subtracting the minimum value from each data point and then dividing by the difference between the maximum and minimum values. Normalization is particularly useful when the data distribution is not known or is non-normal. Example: suppose you have data on the prices of different products. The prices can range from a few cents to thousands of dollars. By normalizing the prices to a range between 0 and 1, you can ensure that all products are treated equally regardless of their price range. Min-max scaling. Min-max scaling is a feature scaling technique that scales features to a specific range, often between 0 and 1. This is done by subtracting the minimum value from each data point and then dividing by the difference between the maximum and minimum values. Min-max scaling is useful when you want to compress the range of features, such as when using algorithms that are sensitive to the scale of features. Example: you have data on the ages of people in a company, ranging from 20 to 60 years old. To scale these ages to a range between 0 and 1, you would subtract 20 the minimum age from each age and then divide by 40 the difference between the maximum and minimum ages. Use cases. Feature scaling is widely used in machine learning for various reasons. Some common use cases include: when features have vastly different ranges, it helps to prevent features with larger ranges from dominating others, ensuring that all features are treated equally by the algorithm. To improve the performance of distance-based algorithms, k-nearest neighbors, k-means distance-based algorithms rely on the distance between data points to make predictions. Feature scaling helps to ensure that these distances are not skewed by features with different ranges. To prevent features with larger ranges from dominating others, features with larger ranges can disproportionately influence the model's predictions. Scaling helps to ensure that all features contribute equally to the model's output. To speed up the training process of some algorithms, such as gradient descent, converge faster when features are on a similar scale. To make the model less sensitive to outliers can have a significant impact on the scale of features, which can affect the performance of the model. Feature scaling can help to mitigate the impact of outliers. Implementation. Scikit-learn provides a variety of tools for feature scaling. Some commonly used classes include sklearn.preprocessing.standardscaler. This class implements standardization, scaling features to have a mean of 0 and a standard deviation of 1. sklearn.preprocessing.minmaxscaler. This class implements min-max scaling features to a range between 0 and 1. sklearn.preprocessing.normalizer. This class implements normalization, scaling features to have a unit norm.